Assalamu alaikum, hello and welcome back everybody. This is Ahmed Nabil and I'm back again with this brand new video. Today's video, inshallah, we're gonna be trying to look at this problem, which is reverse linked list. There are two approaches to solve this problem, and we will try to explain both of those two solutions. The first one uses a normal while loop, and the other one uses a recursive solution. So stay tuned till the end of this video, and this is the goal of this video. We will try to reverse this linked list like this. This is gonna be at the first, this is gonna be the head, and at the end it is gonna be the tail, and vice versa. This is gonna be the tail and this is gonna be the head for this single linked list. So this is the code for the while loop solution. We will try to discuss it and understand how it runs. First, we declared two variables, one which is the previous and the other one is current. Then in the while loop we declared another variable which is temp, which stands for temporary, and it acts like a container, temporary container. We will use it to hold the value of the next element. The condition for this while loop is that the current has a value. So if you walk through this linked list, at the end it refers to null. The next of the tail is just none or null. So this basically means when this loop, when we reach to the end of this linked list, we will stop the while loop. So now we will try to understand this block of code inside of this while loop. First, before this, we will give this previous a non-value, and this current we will take the value of the head, and this temporary we will assign it to a value when this while loop starts. So when the while loop starts, this temporary takes the value of the next to the current, which is this current points to this head, and the next to it is this B node. So the current value of this temporary is gonna be B. Then I like to call those exchange and update. After this, we will take the next pointer of this current and we will set it to none. After this, we will update the current pointer, this one, and the previous pointer. This previous pointer will point to this current, so we will use that. We will assign that current to the previous. So the previous is gonna be here, and will point to this first node, which is A, and this current is gonna be the temporary variable, which was the next of the first node here, and this is gonna be our current, you know, and we will continue doing so till we reach the end of this linked list. So the last and at the end of this while loop, we will return this previous pointer, because it will be at this C, and every next pointer will be modified to be something similar to this. So we will start at C and finish at A. This was a simple explanation for the first solution, and it is the simple one. So this is the recursive solution, and now we will try to understand it. By the way, this solution doesn't need to be more efficient than the previous one. Actually, the previous one is a bit efficient, but we are just trying to open the door for different ideas and different approaches to solve the same problem, to get a deep look, and to be a better problem solver overall. So starting with the explanation, this if statement is used to terminate our recursion, and so I will try to move to another page to get a better look at what I'm trying to explain. So this if statement checks if the head, this head that we start at, if it is empty or its next is empty. So this refers to an empty linked list like this, just doesn't has any nodes. Just this is a linked list which is empty, and this is a linked list that consists of one node, and then its next pointer is set to null. So if this is the situation, we will return the head itself as a reversed linked list. But if it is not like this, we will use recursion and call the function inside of itself, but we will pass it the next to the head, which is, let's say we are at A now. This function is using A as head, so this those two lines of code will modify the A node. But before this, we will call we will make a new variable which is new head, and this will call the same function inside of itself, but here we will pass it the B node. So inside of here we will check if B is empty or its next is empty. This is not the situation here, so we will do the same as we did before, and we will call the same function again, but this time we will pass it the C node. Here the C is not empty, but its next is null, so we will return it as the new head in here. So this is the new head, and we will return it again here as the new head, and this is convenient because we won't see as the new head. So going back to the middle, we have C as our new head, and our head is B. So we are currently at B, and we will modify it like this. We will take this pointer which is head.next, which is C. C.next is just null, and we will take this pointer and we will make it like this. C will point to B, as head.next is C.next is gonna be set to the head which is B, and we will also has this head.next which is this pointer. We will just take it and set it to null for now. Then we will return the new head which is C. Here new head is gonna be C. Also we will modify the A. We are sending currently here, so we will make this null pointer, the next pointer of the B. We will make it point to A, so head.next, head here is A, so this is gonna be B. B.next is gonna be set to A, and A.next is gonna be set to none. And like this is how this recursive solution works. And at the end, this return statement will return the new head which is gonna be C, and we will use C and its next pointer to walk through this linked list. Hope you liked this video. You will find these code snippets in the description below. See you in the next video, and assalamu alaikum wa rahmatullahi wa barakatuh.